Let's go. I am now live on 2 different accounts. This is really epic. This is sad. What am I doing? This is what you get whenever you give a weird kid YouTube. This is funny.
Are you gonna do it like all day or something?
Yeah, all day. Let's go. I can't wait to bring this to lunch. Just gonna be like, okay, guys, let's go get my food. That's funny. I'm actually gonna.
I dream I'm like 7 foot, and I just make them go see the day on my time. It's super fun.
Bye. Have a good day.
I found a way to stream on multiple.
Still live stream?
Yeah. This is fun. I'm gonna hit real life later on. Ayo, Ivy. Definitely didn't find a way to live stream on a school laptop.
Whoa. You a hacker now. Hacker. He's a hacker.
What?
He's a hacker. He's got the live stream with a laptop.
That doesn't even make sense.
Yeah, you're a hacker.
Just out of context, you found out a way to stream on a laptop. Who doesn't know how to stream on a laptop?
You're a hacker.
Just because I found a loophole doesn't mean I'm a hacker.
Boom.
Live streaming right now?
Yes, I am live
Live
streaming.
streaming.
I think Kalia is at.
That's what I thought. Okay. As I'm looking at this, I'm like, Blake is there. Hello, good morning.
Let's just say it's for a project.
Blake is here, right? You're Jacob.
What are you doing for it?
We took a test, and so I'm gonna actually have you come over here
Right now?
and take the test, yes. So if you did not take a test on Friday, you're absent, you should join me over here. Wait, Kylan's here. Megan's here. Tyler, you're here.
Move it, make it boom.
Good morning. Ariana. Here. You get to use your notebook, so previous here.
No, you weren't. No, you weren't. Okay. Maybe you were. I don't remember. I don't remember. Do you think you'll ever put me on my best friend?
You're gonna tuck me up like that's up there? Yeah. Hi, Bruce.
I'll leave it. No, I'm gonna find her. We're gonna go find my soulmate.
Oh, damn. Francis has a fucking sticker on it. France.
No. When'd you ever get that?
What happened to that girl?
What girl?
We're in the hallway.
Which one in the hallway?
That one. That you were talking about, didn't you?
I don't know.
Hey, you know what? We're actually gonna put the candy away. Princess, please. You guys say that.
Hey, bud. Hey, bud.
All right, Jaden, how's it going? Jerry, you have one last day. All right, anybody else here that did not take their test on Friday? You want to come on over, get your computer out? I'll get you all going on the test. Hello.
Yeah, y'all didn't do the test.
Yeah, you guys need to have your masks up and over your nose and your mouth, please. Awesome, thank you. Okay, so you can sit wherever. You can be here, you can be there, and I'll be with you all in just a moment.
All right, so everybody else took their test on Friday? Yep. How's everybody's 3-day weekend?
Boring.
Wish it was longer, yeah. Did anybody sleep in or take a nap over the weekend?
Paul.
It's good to get rested up. So today we're gonna start talking about biochemistry and biomolecules. So, how many of you have seen or dealt with the periodic table? So most of you are kind of a little bit familiar with it. So when I say periodic table, I'm talking about this thing right here. So, what is the periodic table made of? What are the individual parts? Eli, I'll toss this to you. Yeah, elements, right? Perfect. So what are elements made of? Anybody know what elements are made of? Yeah, Micah. Oops, sorry. Yeah, they're made of atoms. Perfect.
I'm gonna actually stop everybody here real quick. There's no need for a computer to be up and open right now. Yep, thank you so much. All right, go ahead.
All right. So we know that it's made of elements, and the elements are made of atoms. So what are the 3 parts of an atom? Can someone just name one part of an atom? Logan, I'm going to toss this to you.
Protons?
Yeah, protons.
Oh, you want all?
You can toss it back. And our protons, what is their charge? Do you remember?
Positive charge?
Positive, that's right. All right.
Neutron.
Neutrons. And what is their charge?
Negative.
It's not negative.
No.
It's neutral. That's right. Was that Anthony that said that? No, awesome. Eli and Reed. Electrons. And what are their charge? Negative. That's right. So the 3 parts of an atom are going to be protons, neutrons, and electrons. So what are atoms? Want to give it a try?
No, not me.
Did you have a guess?
No.
Okay. What are atoms? Yeah.
They're kind of like the building blocks that make everything.
I love that. They're the building blocks of everything. So everything is made up of atoms. Awesome. All right, and then kind of going back to what we talked about last week, what is an autotrope? Oh, you guys are breaking my heart. What are autotrophs? Who said that? What do you think autotrophs are? What does auto mean? What was that?
Like a car.
It means, well, no, you're either thinking automatic or automobile. So auto means self, right? So what does an autotroph do?
It's self.
Sort of, so what does troph mean? Like feeding, right?
Yeah.
So self-feeder?
You feed yourself?
Yeah, so it's an example of an autotroph. Well, not quite. Right.
Wouldn't it be you feeding yourself?
No, so just think about it. We have to eat something else to gain our energy. So that's a heterotroph. An autotroph is something that makes its own food. So when we make food in the kitchen, that's still a heterotroph, right? Because we still have to get it from something else. What's an example of an autotroph?
Plants and photosynthesis.
Yeah, awesome. I'm gonna toss this to you. Okay. So, and then we covered what heterotrophs are. Does anyone have an example of a heterotroph? Yeah, humans, that's right. Okay. So with that covered, guys, we are going to go into the science of macaroni salad. So we are going to talk about the building blocks of life. So has anybody ever heard of the mnemonic device chomps? Okay. Write it up on the board. You can write this down if you'd like to, but you don't have to. So chomps. Stands for carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. So if we look at the periodic table over here, what do we notice about the carbon, nitrogen, and oxygen?
They're yellow.
They're yellow, right? So those plus phosphorus and sulfur are the things that we need to be considered living. So those are why we call them the building blocks of life.
Wow.
All right. So did any of you guys do this graph when we were doing this, practicing the CERs? So this one is talking about the recommendations of nutrient intakes. So here we have the average diet. Here we have a healthy diet. And here we have a sports diet. Talk to your partner next to you and list one thing that you notice that's different between them.
If you have a head over there next to you, turn around to make your group of 3 or 4.
No, they're not. The red's a little bigger.
You need more carbs than proteins if you're trying to be healthy and fit.
All right, so what did somebody notice was the difference between the diets? Eli?
They're different numbers.
Right, they're different percentages, right?
Yeah.
So which diet needs the most carbohydrates? Anthony?
The sport diet.
Right. Why do you think they need the most carbohydrates, Alex? because carbohydrates are gonna help you for protein. Because protein keeps you going. Yeah, so it's for energy, right? So people who are doing sports need to consume more energy products so that they have something to use up. So that's kind of what we're going to be talking about with the macaroni salad simulation. So first thing I'm going to have you guys do is there's going to be an Ed puzzle that you guys are going to do on your own in Google Classroom. You're going to watch the video and then answer some questions. And then after that, there's going to be a build an atom simulation. So you will watch this video and then follow along with the simulator. It'd probably be hard to listen to music because there's videos, so you'll have to listen to the video. All right, so everybody get started with the Ed puzzle.
Did you go over the monomer and polymer?
Yeah, I can do that right now.
Yeah.
You were so stupid, there's not gonna work out.
So one of the things that's going to come up in your Ed puzzle is it's going to ask you about monomers and polymers. What does everybody know about the prefix of mono? What does it mean?
Positive, right?
Mono is
One.
one.
I knew it.
Poly is
No, look at the board over there. Look at the whiteboard. Miss Wenzel's actually pointing stuff out that gives you the answers.
Oh, multi.
multi, right? So a monomer is going to be the simplest component, and that's going to be like amino acids or glucose. But if you combine monomers, they make a polymer, which are bigger things like carbohydrates. All right? So monomer is the most simplest. Polymer is made of monomers joined together.
And there is a question about that, and it's not super specific. So hopefully y'all just heard that, or else you might get a couple of those questions wrong.
Monomers are the simplest. So make sure you start with the Ed puzzle.
CELERY.
Well, that's, see, there's a already needs help.
Things like cats and macaronis. And macaroni salad is made of things like mayo and mustard and celery, which are all made of molecules. As we'll see, these molecules. We already know that the world is made of things. things like cats and macaroni salad. And macaroni salad is made of things like mayo and mustard and celery, which are all made of molecules. As we'll see, these molecules are made of the same stuff, just mixed together in different ways. Let's go back to our macaroni salad. We've already unmixed things physically as much as we can. Now we'll go further and unmix things chemically by breaking some bonds. Many larger complex molecules are just a bunch of smaller molecules bonded together like building blocks. Here again, macaroni salad provides a nice example. If you look at the pasta, you'll notice it's made of a lot of this stuff. Starch, which is this molecule, otherwise known as amylose. Turns out, if you break some bonds, amylose is made up of smaller molecules of glucose, a simple sugar. If you take a bunch of these same
So remember what she just talked about on the forward about monomers and polymers? Which is the simplest one? Monomer, yeah, so what is glucose? So that's the simplest one. So,
same glucose molecules and rearrange them in a different way, you get cellulose, which is what plants are made of. So while this piece of pasta made of amylose and this wooden spoon made of cellulose look vastly different, they're both essentially made of the same molecules, just stuck together differently. This type of breaking apart and recombining is what goes on when you digest food. The complex proteins found in the foods we eat, like carrots and eggs, can't be used by our bodies because we are not carrots or chickens. What we can use are the smaller molecules that make up these proteins, the amino acids. During digestion, our bodies
amino acids, yeah. So amino acids is the simplest.
break these proteins up into their amino acids so they can be rearranged and put back together to make human proteins. But let's keep breaking bonds. All molecules are just made up of atoms bonded together. If some molecules are building blocks, atoms are the building blocks of the building blocks. And you'll notice that with the molecules from macaroni salad, the same 6 types of atoms keep showing up. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, or CHOMPs.
Not now, roadside, just got a question.
I gotta move you, one of you. You guys can't be. You can, but it's gonna cause a disruption. If you really anything.
Hold on.
See this? And then I will frame the edges, so you're taking those.
So when you're finished, this is the green one, and then this is going to be a quick video, and this is going to be the simulation.
There's a few others, but the big 6 is what macaroni salad is made of.
Okay, guys.
If we
when
went a
you're
step
finished with the
further, we could use
puzzle,
these
you're
same
gonna do a
atoms,
build an
recombine them,
atom
and make
activity.
other stuff like gasoline or sulfuric acid, methane, and nylon. It's all made from the same elements that make up macaroni salad. So, to recap, everything is made of atoms. They are the stuff that things are made of. Atoms are grouped together in different ways to form molecules. These molecules are constantly being combined, broken apart, and recombined. They get thrown into mixtures, separated, remixed, over and over and over again. The stuff that things are made of is always in flux. It's always changing. Macaroni salad is only macaroni salad for a short time. You eat it, Some of it becomes part of you, the rest eventually goes into the ocean and gets eaten by other animals that die, and after millions of years they turn into oil, which is where gasoline comes from. And that's why gasoline and macaroni salad are not that different. They're both made of the same stuff. Just one tastes better.
Okay, so go ahead and just watch this video. When you get up to that. So I would watch Tyler. Did you already do the egg puzzle?
Yeah,
Yeah, I'd watch that video real quick. It's kind of elementary, but it gives you a basis for a periodic table.
all right.
Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these three particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly 1 electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are 1 electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Poor metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements. Well, I've seen tables with elements going all the way up to atomic number 118, but any element above 92, uranium, is too unstable to occur in nature and has to be made in a lab. Another cool thing about this table is that because it's based on number of protons, and you can't have half a proton, scientists are pretty sure there aren't any holes in the table. Using an early version of the table, scientists were even able to predict the existence of elements like neon and germanium before they were even discovered. Yeah, see? Well, that wasn't too hard, was it? Yeah, Moby, you give up too easy. He faints too easy, you ask me.
Now, click on that charge and click on that. Yep. And so now, what's the net charge of that?
So what are you supposed to be doing?
What's the mass number?
Right here it says to click an orange button that says run HTML5. Where's that at?
Say that one more time.
It says to click an orange button that says run in HTML.
Okay. So go ahead and click the play button,
So,
Adam.
the charge.
And I think that's the orange button that it's talking about. So that will reset it. Okay. So it may help to do it in a split screen so you can have that open plus your document open.
Alright. Where'd my thing go?
So what cut?
There we go.
So do I have to like enter these numbers onto this?
So what you'll do is you'll actually click and drag the
All right, I'm gonna give you all
circle.
just a quick clue. So over on the right, when you guys are building the atom, you actually have to click on the green dot that says net charge and the green or green plus that says net charge and the green plus that says mass number, so you can actually fill out that chart.
Yeah,
And
so
keep those,
the
yeah.
plus right
So you're
there
gonna wanna click here,
on both of them.
that's what you're doing. And so where's your doc that you're gonna use?
And so what you're gonna do is you're gonna follow
There you
it
go. So if
directly
you wanna
as it
split
says. So you'll do
screen them,
one
like-
proton,
See
0
what he's
neutrons,
doing?
1 electron
Where you can fill
And
out
then
and
look
type
at what
in
it
the
says.
thing at the same time.
Okay.
for the net charge and mass.
Okay, so
So,
open up a new window.
One
Hang on.
proton, no neutrons, 1 electron.
Wait, you don't
So,
want to open up a window on
net
there. You gotta open up
charge.
the- So go up here,
0,
say file, new window,
mass, 1,
okay? And then
element,
make everything not full screen. Make it
H.
all where it's- There you go. So now go back to where you just were.
Okay.
Like, I'm gonna push this, and then here.
One to us.
Okay, so now, can I touch your computer? Okay. We want to get
0,
that
2,
worksheet. Okay, this is the
H.
worksheet, right? We want to get
1,
this.
2,
Game.
Are they supposed to be all later?
Okay, so once again, it's age,
Not all of them, but you'll see.
mass number 2.
Does anybody have their hand up?
There's this part
Yeah, so now you are building an atom.
-1 charge,
Filling out this table.
222.
Okay, so like, you're gonna
Let's
put one
just
proton
add
and one
1.
electron.
0, 4, H, E.
So you're gonna say, what's its net charge? 0, and it's, and then you'll just create each of those.
He, neutron.
You put it again, yep. Because it's gonna start, you'll start seeing a pattern, and you should start to notice a pattern in the periodic table. Can you not see? Yeah. Okay, sorry. Jerry, what's up? Can I help you with something?
+1.
Oh, yeah, okay. So can I have you rewatch it real quick and just listen to like things that are in that room? Or don't look at that, that's not, yeah, just. Yeah, and then watch it. Well, sometimes the people watch it. Sometimes I don't. So. That's it. So what's in macaroni salad? Mayo, mustard, and celery and lettuce, and if you saw the picture, and that's what you just did for free. And then you, yeah. So y'all got with yourselves over here. One of everything, right? So where is it take out one? Is it yours to plug in now? How am I gonna get your answers? Well, you just did them in the notebook right now, and I can just put them in, and you don't have to do it via the question. That's fine. Are you good? Okay, so, all right. And by the time that some charges should be pulled out and work for it when it's plugged in, right? Jay, did you understand?
Number 2 has a neutron. This one.
Okay. Oh, good, good, good. So you guys did do some periodic table stuff.
No.
Yeah, and we won't do anything too crazy, so good. Leah, how are you? Okay. Leah, you doing okay? Okay. Megan, how are you? Tyler, you look like you're getting there. And Jerry, how's it going? Good. What's the matter? You sent it from that. That's all. See how we- So what is the charge